So, we just studied about the GP and axioms. Now, the next topic is algebraic properties of real numbers. Okay, so you know that we denote real numbers as R. Okay, so now let's take some properties of this. First one is system R is a field. Then what is this field? Okay, what is this field and field axioms? This particular topic we'll be discussing in next lecture. Okay, so no need to worry. You just know that system of R is a field. Then it have field axioms. If it is a field, then obviously you will be having field axioms. Okay. So the third one is important actually. This is important. It includes binary operations. Okay, over multiplication and additions. Okay. So this binary operations we will be discussing over here. There are 10 points. These properties you have to remember, and as you already know these things, okay, this is not that much complicated. First, that topic, what is called? Now the first property what it says is a plus b is equal to b plus a for all a b belongs to R. This you know. Okay, if 1 plus 2 is equal to 2 plus 1, that you know. And 1 and 2 both should be lie inside our R set. Now second property what it says, a plus b plus c is equal to a plus b plus c. That means if you are taking 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. Simple. This is 6 and this is also 6. Next, this is conditions for existence of 0. That property. Okay. There exists 0 in R. Okay. There exists 0 in R such that a plus 0 is equal to 0 plus a is equal to a. Means if you add any natural number with 0, it will give rise to the same number. If you add 5 plus 0 is equal to 0 plus 5 is equal to 0. Okay. Oh, sorry. 5. Mistakes. Sorry. It will give rise to 5. Okay. Small mistakes happen there. Okay. Then the next property. If for is a belongs to R, there exists minus a belongs to R such that a plus minus a is equal to minus a plus a is equal to 0. This is actually the existence of negative numbers in real numbers. Okay, that means you can find a multiplicative of additive inverse of any number in R. Okay, if you take 5 and its additive inverse is minus 5. Okay, if you add 5 plus minus 5 it is equal to 0, and same way minus 5 plus 5 is also 0. This is the same property, that is existence of 0 and negative numbers. These two properties are somewhat important. Okay, then a simple thing I want to say is all these 4 properties we studied now, this is up to this much additive properties. Or you can say real numbers over additions. Then 5, 6, 7, 8, these 4 properties are addition, multiplications, binary operations on multiplications. What is it? Similar way, a dot b is equal to b dot a. 5 into 6 is equal to 6 into 5. Okay, for a, b belongs to R. Simple thing. Next 6th number is a dot b dot c is equal to a dot b dot c. Means if you write the same way, 2 into 3 into 4 is equal to, let me give multiplication sign, 2 into 3 into 4. The result will be same, no changes over here. You can try this one. Okay, I'm not lengthening this one, as you know all these things. Then the 7th point, there exists 1 belongs to R such that 1 dot A is equal to A is equal to A dot 1. Okay, what is this one? This is the existence of one, I think. Existence of one or unit element. We call one as unit element. Okay. If you see, if I multiply 1 with any number 6, I think. Okay, 6 is equal to 6 into 1, it will be 6 only. Same here it is written. A into 1 or 1 into A is equal to A into 1. Okay, for all A belongs to R. Nothing hard in this one. Then we are going to the 8th point. For each A is not equal to 0 in R, there exists 1 by A belongs to R such that A into 1 is equal to A into 1 by A is equal to 1 is equal to 1 by A is equal to into 1. This is kind of confusing. You might get confused in this one, but it is kind of simple actually. Okay, it says if A is not equal to 0 and this belongs to R set. Okay, it belongs to R set, and there also exists 1 by A in R, then A into 1 by A is equal to 1 by A into A is equal to 1. Okay, this condition A is not equal to 0, why it is there now? If A equal to 0, then 1 by A is infinite, and there is no such infinite term because it is a hypothetical term. Infinite is a larger number, but it has no values. Okay, so 1 by 0 is undefined, so we take A is not equal to 0 except 0. If you take any number, it will satisfy. Okay, this is all about number 8 property. Now let's move toward the last property. Last two properties actually, 9th and 10th. What it says, E dot B plus C is equal to AB plus BC. Okay, this you know simply. Okay, we will be multiplying A with B, then A with C. AB plus BC, because plus sign is there, it will become plus sign. Similarly, the same property over here, B plus C whole into A is equal to B will be multiplied with A, C will be multiplied with A. BA plus CA. Easy only. So, lastly, what I want to discuss with you is what are these all? Okay, and which contains which property? You see, A plus B is equal to B plus A. It is commutative property. It is, I write it here, commutative property. Okay, so next is associative property. This one is associative. Then the third one is existence for zero element. Okay, zero element. Then the fourth is existence of negative numbers. Okay, these are all what is called mm, these four are addition rules, these four are multiplication rules, and these two are distributive laws. Okay, that's all. This is all about the algebraic properties of real numbers.